So we know the law of sines, and now what we're going to do is we're going to employ the law of sines to be able to find the missing components of triangles. Okay. So for instance, we have this triangle that's constructed out for us. So we have an angle of 46 and an angle of 63 degrees. And then we also have one side. Okay. So we have an angle side. Okay. Kind of scenario that's going on here. All right. So what I'm going to do first is I'm going to find this missing angle right here, angle B. We know that the sum of the interior angles is 180 degrees. So to find B, B is going to be equal to 180 minus 46 degrees and minus 63 degrees. Okay. And we can just throw that into our calculator. Okay. Or it's going to be 180 minus 79. Okay. Or I'm sorry, 109. And so that should be 61 degrees. Okay. Or 71 degrees, excuse me. Sorry about that. But we can always verify it by using our calculator. So in our graphing calculator or our scientific calculator, we can take 180 minus, it was 46 and 63. Okay, and we get 71 degrees. Okay, so that's an easy one. Okay, everybody's able to do that. And you don't need the law of sines to do that. Okay, so this is just our 71 degrees right here. Now, let's try to figure out angle side A. Okay. And we can use the law of sines. Okay. And remember, our law of sines is that sine of A divided by A is equal to sine of B divided by B. Okay. And we can use, or sine of C divided by C. And we should use C because we know the side of that. Okay. So I'm going to use that the sine of A divided by A is going to be equal to the sine of C divided by C. Or if I was to go through and solve this for A, it might be a little bit easier to use the reciprocal of this. Okay, so if you're looking for a side, in this case, I'm looking for side A, right? Let's do this. Let's write this as A over sine A is going to be equal to C over sine C. Okay, so we're just going to use that part of the law of sines. Now, in this case, side A is unknown, but angle A is known to be 46. So that's going to be the sine of 46 degrees. Side C is known to be 56. And then the sine of C, we know that angle C is 63 degrees. Okay. What I can do is I can multiply both sides by the sine of 46 degrees. Okay. And so A is going to be equal to 56 times the sine of 46 degrees. And then I'm going to divide that by the sine of 63 degrees. And at this point, I'm just going to throw that into my calculator. Now, we know that since A is the smallest angle, A should be the smallest side as well. Okay, so if you look at these angles, okay, so side B should be the longest, side C should be a middle, and side A, because it's opposite of the smallest angle, should be the smallest side. All right, so we have 56 in our scientific calculators. We have 56 sine, and we're going to make sure we're in the degree mode. We had 46 and 63, sine 46 divided by sine of 63, and I get 45.2. Okay, so I'll just round it off to one decimal place. Okay, now the last thing we have to do is so now we have that A is 45.2, all right, and certainly that's smaller than 56. Okay, so far it checks out. Now let's try to find angle or side B. It's the last side we have to find, all right? And so what I'm going to do is I'm going to say that B divided by sine of B is going to be equal to, we could just use C over sine C. And we already know that C over sine C is 56 divided by sine of 63. Right? Excuse me. And then for B, well, we don't know what side B is, but we know that angle B is 71 degrees. So this would be sine of 71. I can multiply both sides by sine of 71. So I get 56 sine of 71 divided by sine of 63, right? And the good news is, in my calculator, we have 56 and 63 already. Okay, so all I have to do is just replace 43 or 46 with 71 in my computations. Okay, so I'm just going to flip this over, make this a 71. I get 59.4, okay, for B. Okay, so this means that B is approximately 59.4. And that makes sense over here on the triangle because notice that it's opposite of the largest angle. Okay, so it should be the largest. Okay, so that's how we go through and try to find these missing components. Another example, we have A is 41, B is 67, C is 42. So we're going to have to draw the triangle for ourselves. No big deal. Okay, let's start by finding what angle C is. Okay, so angle C is going to be equal to 180 minus 41 degrees minus 67 degrees. Okay, we can just do that in our calculators. So we have 180 minus 41 minus 67, so we get 72 degrees. Okay, so that means that C is going to be 72 degrees, right? And so that way, when we construct our triangle, now we know what we're kind of looking at. Okay, so I'm just going to draw something like this. They're not all that far apart. Okay, so if I call this C, which is 72, I'm going to call this side C, which is 42. And then if I call this angle, let's call this one B, just because we can. I'll call this side B, okay, and B was 67 degrees. And then obviously this would be A, and A is 41 degrees, and this is side A. So what we are really tasked with is just finding two sides at this point, side B and side A, right? Now we need to use C in our law of sines, okay? So what I'm going to do is I'm going to say that side B divided by the sine of B, which is 61 degrees, is going to be equal to side C, which is 72, divided by the sine, I'm sorry, side C, which is 42. And we're going to divide that by the sine of 72 degrees. Okay. And so, just like we did in the previous, we're going to multiply both sides by sine of 61. So B is 42 sine of 61 degrees divided by sine of 71 degrees. And then we could just shove that in our calculators if we wanted to. So we have 42. In fact, I'm just going to copy this. And we'll have 42 sine of 61 and 71. Okay, so that'll be 61 and 71. All right, so we get 38.9 is going to be the side B. Okay, and so that makes sense because it should be smaller than 42. Okay, so B is going to be 38.9. Okay, so that's done. And then finally, let's just use the exact same ratio for C. Okay, but let's find side A. Okay, so we're going to say that A divided by the sine of A, and A is going to be 41 degrees. So sine of 41 degrees, that's right here, is going to be equal to, we could just use this ratio again, C to C. So 42 divided by sine of 71 degrees. I'm going to multiply both sides by sine of 41. So A is going to be 42 sine 41 degrees divided by sine 71 degrees. And the good news is we can just recycle almost all of the previous statement. We're just going to replace 61 with 41. Okay, so remember we had 42 sine of 41 and then divided by 71 sine. So we end up getting 29.1. Okay, so for side A, this is 29.1. Okay, so A is approximately 29.1 feet, meters, kilometers, yardsticks, whatever it might be. All right. Certainly that makes sense because angle A is the smallest. This should be the smallest side. Okay. By the way, notice that we said it was the ratios, and the closer the angles are, the closer the sides, the measures of the sides should be. So these are only about maybe 3 units apart. Okay. That's because the degrees are only off by 11. Over here, though, notice that this is off by about 20. Okay, so these are going to be off significantly more than just 3 degrees. units. Okay, so keep that in mind that it is a ratio as we're going along to do this. Great. So that's how we use the law of sines. Okay, it's not meant to be too difficult. Okay. In the next video, what we're going to do is we're going to start taking a look at ambiguous cases. Okay, so what happens when we might have like one angle and two sides? Okay, and how's that going to affect our process?